If we look at the tutorial 11, this is the last day of week 14. We are going to cover for Gauss Theorem and the Stoke Theorems. So we look at the question 1. Given a vector field F equal to 3xi plus xyj plus 2yzk and S is the oriented outward surface of the cube bounded by the planes x equal to 0, x equal to 1, y equal to 0, y equal to 1, z equal to 0, z equal to 1. Use Gauss Theorem to evaluate the plug integral f dot n d. S here is a capital S, stand for 1 unit of surface area of the plane here across the surface S. If not use the Gauss Theorem, then you have to do your plug integral 6 times. Mean you have the 6 surface here, 6 surface. Each surface they have a different unit normal vector, where x equal to 0, your normal vector is n equal to negative I, x equal to 1 is n equal to positive I, y0 which is n equal to negative, y0 is n equal to negative j, y equal to 1 is n equal to positive j, z0 is n equal to negative k, z equal to 1 is n equal to positive k. You may refer to the second example of the Gauss Theorem there. You have to do it 6 times, sum it, then you get the answer. So it's troublesome and wasting time. Since the surface is closed and oriented outward, you can apply the Gauss Theorem. So now, we are going to solve the first questions. We are going to solve using the Gauss Theorem. Gauss Theorem states that the plug integral f dot n d S across the surface S. Some book they use a sigma, stand for your surface S. Doesn't matter, there's only the symbol. By using Gauss Theorem or Divergence Theorem, because it's invented by Gauss and it uses a divergence of F. With del dot F become dV across the solid sheet. So means you have to find del dot F here is called as divergence of F. So you keep doing the divergence of F first. Divergence of F, where the del is a differential operator. If the F is 3 dimensions, then the del operator will be 3 dimensions, which is del xi, and then del yj, del z, dot with the F, which is 3xi, xyj, 2yzk, dv. So you do the dot product first. Doing the dot product here, this is calling as divergence of F. So you del x in del x 3x plus del y here xy plus del z 2yz. So del x 3x you have 3, del y xy you have x, del z 2yz you have 2y. So now become the problem of triple integral. Where's the solid? Because you have the 6 surface and then it forms a solid where bounded in dv I use dz dy dx, or you treat another way also doesn't matter because the limit is constant. Plus 2y dz dy dx. So you integrate respect to z first. So when you integrate respect to z, 3 plus x is constant. So you have the constant time z. Everything is constant, 3 plus x plus 2y. Y and z from 0 to 1, dy dx. So 3 plus x plus 2y dy dx. Once we integrate respect to z, all here 3 plus x plus 2y is constant times z. Plug in z from 1 to 0, you get 1. So you leave it to double integral 3 plus x plus 2y dy dx, where the y from 0 to 1, x from 0 to 1. Okay, now integrate respect to y. So when integrate respect to y, 3 plus x is constant. So you have a constant 3 plus x and y plus 2y. Then integrate from 0 to 1 dx. This one, 3 plus x plus 2. Plug in 0, this 0, this 0. So you get 3 plus x plus 2 dx. So it's 5 plus 2 x dx. So you can use calculator, or you want to evaluate it manually. So 5 plus half. The answer is 9 over 2. Let me check why it's a mistake. Delta x3, x, we have 3. Delta y, xy, we have x. Delta z, we have 2y. So integrate respect to z, we get back the same thing. 3 plus x plus 2y. So integrate respect to y, 3 plus x. Okay, 3 plus x and y plus, here. Mistake is here.
What's the
Yeah, this one, y squared. So 2y squared divided by 2, this is y squared. So that's why this is plus 1. So this is 4 plus x. So this is 4x. So 4 plus half, okay, which is 4.5. So now this is correct. 9 over 2, or 4.5. Okay, so this is the first question. Okay, basically the Gauss theorem, make sure the surface is closed and oriented outward. Then the plug integral here will be equal to triple integral del dot f dv across solid G. Okay, so any questions here?
okay?
Olivia, are you here? No, Nadira? Exam a bit faster. We should do a bit longer. Exam take question 3 shorter bit. Question 2, please correct the answer. The answer is 5/48. Question 3, this one is longer. We will jump to question 3 a bit shorter because we're going to have one more Stoke theorem and then half an hour will be the last quiz. Question 3. Okay, given the vector field f x y z equal to xi plus yj plus zk across the surface S, which is enclosed by z squared plus y squared equal to 4 between the plane x equal to 1 and x equal to 0 in the first octant, use Gauss theorem to calculate the outward, and surface is closed. Okay, can you tell me what is this surface? Z squared plus y squared equal to 4. What kind of surface there? What is the surface there? Z squared plus y squared equal to 4. Okay, what's the surface here? In 3D, yeah? Do you mean? What's the surface here? Z squared plus y squared equal to 4.
Surface, circle.
Okay, correct, circle, but 3D become?
3D. Is it cone?
Circle, okay. When you pull up, how to become a cone? Cone.
Sphere. Sphere. Yeah, sphere.
Oh. Cylinder.
Oh, sorry.
Okay, the circle equation in 2D is circle. In 3D, you imagine your water tumbler or tanglong with cylinder shape. You press it, it becomes circle, right?
Yeah.
So, because if you say, even though sphere, the sphere tanglong you press it, you get circle also, but sphere, make sure you got 3 terms, x squared plus y squared plus z squared equal to 4. That means sphere. So this is cylinder. Okay, and this cylinder, you don't have normally cylinder you see is x squared plus y squared, right? And the cylinder is vertical. Because without z variable, the cylinder is parallel with your z axis. And now this one without x variable, your cylinder is actually parallel with your x axis. Okay, look back your assignment that you have done. You have your x, y, z. Okay, this cylinder without the x variable, so it's parallel with x axis. Okay, and the projection here, the radius is 2 units. And they say it's first octant only. So mean the cylinder you cut into 4 parts. And here, this is 1. X from 0 until 1. Okay, my ratio is not the cylinder. Because in the first octant, that's why you take your water tumbler, cut into 4 parts. Take 1/4, okay, of portion only. Normally, your cylinder x squared plus y squared equal to 4. So it's vertical. Now the cylinder parallel with the x-axis. Okay, and then when you press the cylinder here, press it, you will get the projection on ZY plane. This is why this is a Z, because in first octant only, that's why it's only quadrant of the circle. So this is a Z squared plus Y squared equal to 4 in the first quadrant only. Okay, and then now we solve the Gauss theorem. The triple integral del dot F dp across solid G. Okay, then we do the del is del del x I, del del y j, del del z k. Dot with the F x y z. In the x I, y j, z k. dp across solid G. So this is so-called divergent or Gauss theorem. So you do the dot product. Delta x, x. And you do it one by one. So the answer is 3 dB. Delta x, x you have 1. Delta y, 1 you have 1. Delta z, z you have 1. So answer is 3 dB. Okay, it means this is a 3 times of the solid. Okay, it's actually 3 times of the volume of solid G. 3 times of the volume of the solid G. Your solid is a cylinder. Okay, cylinder parallel with x-axis, where the height is actually 1 unit, and in the first octant means you have only 1/4 of cylinder. So here I can just use a formula of cylinder, volume of cylinder, which is pi r squared times h, and the cylinder is 1/4 only because in the first octant, okay, the radius is 2, height is actually 1, so divide by 4. That's why the answer you have here is 3 pi. Okay, this is without using triple integral, because we know this notation stands for volume of your solid G, which is cylinder. The cylinder is in first octant, so it's 1/4 only. So you get 3 pi. Okay, if you want to use the triple integral, since if I want to use a triple integral, I will use a cylindrical coordinate, but the projection is ZY plane, ZY plane, and cylinder is parallel with x-axis, so I will integrate respect to x first. So mean you have a dx, and then the dA, when the projection is ZY plane, we use a polar combination of the polar and the dx. This is cylindrical coordinate, so this is r dr theta. Okay, cylinder bounded from x0 until 1. Okay, dr, the radius of the cylinder is 2 unit. Theta in the first quadrant only, so 0 to pi over 2. Okay, of course, the easiest is the first one, using the formula of a cylinder. But if you want to test your knowledge of triple integral, then you can use this one, cylindrical coordinate. Okay. And then you integrate. Okay, 1 with r dx, or you have here, this is x, 0 to 1 r to theta. So we will get this one is 0 to 2 r dr to theta. Okay, next integrate respect to r. So we have r squared over 2, 0 to 2 to theta. This is 4 divided by 2 to 6. Integrate 0 to pi over 2 to theta. So answer we have here 6 times pi over 2, where the answer is 3 pi also. So this is using the triple integral, but I use I saw the cylinder parallel with x-axis, so I integrate respect to x first, and the projection is actually the quadrant of circle. So the dz dy I use r dr d theta. R dr d theta. So x from 0 to 1, r 0 to 2, theta 0 to pi over 2. The easiest is this one. Second one using cylindrical coordinate. Okay, or if you view the this one cylinder here parallel with your z-axis, then from z squared plus y squared equal to 4, then you make z as a title. And just now the third one, or we have 3 times integral dv over solid g. Okay, you see your z squared plus y squared equal to 4. If dv you want to use dz dy dx, then makes a z as a title, which is square root 4 minus y squared. And then the projections, if you use dz dy dx, you need the projection of xy plane. So this is y, so this is y, this is x. If we use dz dy dx, x bounded 0 to 1, y bounded 0 to 2. So it's a rectangular region. This is 1, this is 2, this is a region R. Then x 0 to 1, y 0 to 2, z 0 to 4 minus y squared, dz dy dx. If you use dz dy dx, so integrate 1 dz, you have z, then you get this z, and then the z 0 to 4 minus y squared dy dx. Plug in the limit, you have 3 times 0 to 1, 0 to 2, square root 4 minus y squared dy dx. If you use Cartesian coordinate, here if you don't use the calculator, then you have to use a trigonometric substitution, will be a bit longer. So you can use your calculator here. Integrate square root 4 minus of course y in calculator you have to change to x square 0 to 2. In this case, this is 13 point, but actually this is actually the pi. Pi is 3.14 something. So this part you get pi dx, and then lastly integrate 3 pi respect to x from 0 to 1, you get the answer is 3 pi. So show you three ways. Your divergence or Gauss theorem is only actually up to here. The rest is your skill or the base in chapter 2. This is it. But this question, if you understand this notation stand for volume of the solid G, which is a cylinder, then you use a formula of volume of cylinder. You can get quickly answer is 3 pi. Okay, or you want to use a triple integral. You have two ways. Is either you see the surface. For me, I will use this one. I see it cylinder parallel with x-axis. I integrate respect to x first, where x from 0 to 1, and then cylinder I press it. Okay, so you get the projection on zy plane. This is a circular. Then dz dy. In your dz dy, you use r theta. Okay, but be careful if you use this one. Okay, here z is actually r sin theta, y is r cos theta. If you use the integral dz dx dy, vertical variable will be r sin theta, horizontal variable is your r cos theta. Because normally we do it dz r d theta. So your y is r sin theta, x is r cos theta. This is another way, but luckily this question you don't have to plug in the variable x, y, z. So you can still get it correctly, or you use a dz dy dx. So okay, I'll show you two questions for the Gauss theorem. Do you have any questions here?
No, betul.
We move to the Stokes theorem. So question 1. Okay, for the Stokes theorem, take the question 1. Okay, given the vector field fxyz equal to 2xi plus 3x squared y plus 3z squared k across the surface S, which is part of the field x squared plus y squared plus z squared equal to 4, okay, for which z is greater and equal to 0. So this is field. You see field, you have a x squared, y squared, z squared, all are positive and is squared equal to 4. So this is a field, but this field is only the part z greater than equal to 0. So means you will have actually is hemisphere. Because z greater than equal to 0, that's why your z is square root 4 minus x squared minus y squared. Okay, you have actually is hemisphere. Half of the sphere. Hemisphere. Okay, upward orientation means your sphere, your hemisphere is the unit normal vector is oriented upward. The radius 4 is radius is 2 unit, 2 unit, 2 unit. Okay, the unit normal vector is pointing up. Use Stokes theorem to evaluate the line integral where the curve C is actually on the here. The curve C is on here, xy plane. Because the circle x squared plus y squared equal to 4. Okay, when z 0, z 0, you have the circle x squared plus y squared equal to 4, where your 2D plane. This is y, this is the x. So this is a curve C. Okay, if the unit normal vector pointing up, you can use a right hand side thumb to represent the unit normal vector, and then the direction of the curve C represented by the direction of the other finger. So if the thumb pointing up, your direction of the curve is anti-clockwise. Okay, if you turn the thumb down, you can see the direction of the other finger is actually clockwise. Okay, And then if they ask you to use it to evaluate the line integral using the Stoke theorem, so means it's actually you evaluate the flux, okay, in the curve of F. Exactly in this one, F dot dr. If they say Stoke theorem, then you evaluate the curve of F dot n ds across surface S. So if you use line integral, of course this one can also use the line integral because it's only one curve. Not like in the second example in the lecture notes, we have the tetrahedron tetrahedron surface, then you got three curves, then will be faster we use the Stoke theorem. Like just now your test. If the curve C is like this tetrahedron, then you have C1, C2, C3. Okay. Furthermore, the line, the curve C1, C2, C3 in 3 dimensions and difficult to get the parametric equation. So this one, then instead of you evaluate the F dot dr, you evaluate the Stoke using the Stoke theorem del dot F dot n ds cross surface S. In this example, C1, C2, C3, if you do the line integral, you have to do it 3 times. Furthermore, the curve is 3D, is a little bit tedious to get the parametric equation and troublesome to do the line integral. Okay, but this example actually is not difficult to do your line integral in 2D. In this one, you can actually do this part. But if the question 1 give you evaluate the line integral and they said use Stoke theorem, you have to evaluate the right hand side. If you evaluate this one, we will give you full marks there. Okay, so now you have to find the curve of F first. Curve of F. You do the curve of F first. Okay. Curve is a del del, mean the del cross F. This is J, this is del del Y, J. Okay, you have the del del Z, K. Okay, and then looking back, what is a vector F? 2x, 3x squared, 3z. Then you do the cross product of a vector. The result is a vector. So your vector, you should have the component I, J, K. Okay, now to get the component I, you cross your column I. Then you do like you do, find the determinant of matrix 2 by 2 in here minus J cross K, the answer is positive I. So you have del del Y 3z squared. So doing cross product, make sure you do it carefully. You have the del del Y 3z squared minus del del Z 3x squared. This at the component I. Then component J is actually component J I cross K, the answer is negative J. So this one negative. So you del del X, cross it, del del X 3Z squared minus del del Z 2x. I cross K is negative J. Okay. Then now doing the component K, del del X 3x squared minus del del Y 2x. So it as a component K. Simplify it. delta y 3z squared 0, delta z 3x squared 0, so component I is 0. Component j, delta x 3z squared you get 0, delta z 2x you got 0, j is 0. Component k, delta x 3x squared you have 6x, delta y 2x is 0, that's why you got 6xk. So this is a curl of f. Curl of f. Okay, the Gauss theorem is called divergent of f. So you have found your curl of f already. Now, f dot r plus. Using the Stoke theorem, it becomes the plug integral curl of f dot n ds across surface S. Okay, and the curl of f that you obtain is 0i 0j 6x dot n. Okay, the unit normal vector is pointing up. Hence, your normal vector is negative zx, negative zy, positive 1k. Okay, this is normal vector. If you want unit normal vector, you have to divide by magnitude of a vector. Magnitude of a vector, you have a square root. You square each component. So you have a zx squared plus squared component j, you have zy squared, add up squared component k, which is 1. Okay. This is the formula for unit normal vector pointing up. Okay, ds, 1 unit of surface area that you see is a formula with the surface area in double integral. Have the formula zx squared plus zy squared plus 1 become dA. Because ds, your surface is 3D. So in 3D, the formula is square root zx squared, zy squared plus 1. To project it on, it means dA on region R. Okay. And then now, this square root and square root cancel. So you get is a R dot with negative zx, negative zy, 1 dA. Okay, 1 dA. So to get your zx, zy, so this is the z here. You have z is actually square root 4 minus x squared minus y squared. Your z is from sphere, you get hemisphere, which is 4 minus x squared minus y squared. Okay, to get zx is, and square root is actually power half. So zx is actually, you have half, indeed, delta z, delta x. 4 minus x squared minus y squared. Because for differentiation, power you bring front, so you have half. And then half minus 1. For differentiation, your power you minus 1, so become minus half. And then you delta x, 4 minus x squared minus y squared. So that here, 2. Okay, power negative half is here, you become square root at the denominator. So 4 minus x squared minus y squared. Here, delta x, 4 minus x squared minus y squared, you have negative 2x. Simplify it, you will get negative x over square root 4 minus x squared minus y squared. Okay, similarly, if you do for zy, you will have negative y over square root 4 minus x squared minus y squared. Cos zy, the difference is only delta x here, you change it to delta y. Okay. So this is zx. So negative zx, we have positive x over square root 4 minus x squared minus y squared. So negative zy, we have positive y over square root 4 minus x squared minus y squared. Okay. Back here. 0i 0j 6xk dot without negative zx become positive x over square root 4 minus x squared minus y squared. Negative zy become y over square root 4 minus x squared minus y squared. Okay, component k is 1. Okay, dA over region R. Okay, we do the dot product first. Okay, the dot product. Okay, component I 0 times. Okay, anything you get 0. Component J also 0 times anything you get 0. Okay, so you just left component K. 6x times 1 to become 6x dA over region R. So after you solve the curl of f, you reduce to double integral problem, which is double integral 6x dA over region R. Okay, the surface is hemisphere here. Projection is a circle with radius 2 units. So this is a region R is circular with radius 2 units, and the projection is involved quadrant 1, 2, 3, 4. So we use the polar coordinate where the R is 0 to 2, theta is 0 to 2 pi. Here, theta 0 to 2 pi, R 0 to 2. Okay, x is R cos theta, dA is R dr d theta. So total, okay, don't forget total you have here 6r squared. So 0 to 2 pi, integrate 6r squared, so you have 6r cubed divided by 3. So r from 0 to 2 to the cos theta to theta. And then r, substitute r by 2, so you have 8, so total you have 16, 0 to 2 pi cos theta, theta. Okay, integrate cos theta, the answer is sin theta, 0 to 2 pi. Okay, sin 2 pi, answer is 0. Sin 0, answer is 0. What about 16? Sin 2 pi is 0, sin 0 is 0, that's why the answer is 0. So that's why this question you obtain the answer is 0. So basically, if they give you the line integral and they ask you to use the Stoke theorem, you have to evaluate the right hand side. The plug integral del cos f. Then you have to find the curl of f first. Okay. And then n ds is like your normal plug integral to split. So any question here? This is for using the Stoke theorem.
Noted.
Okay, and as I said here just now, this question is actually, if you want to evaluate the line integral also, okay, it's not difficult because your curve C is on xy plane, and is circular, then you can easily get your parametric equation. Okay, but if you want to evaluate this one, f dot dr, also not that difficult, okay, because your curve C is 2D, mean your curve C 2D circular. This is your C, this is 2, negative 2, anti-clockwise direction. Then you can use the x actually similar to polar coordinate. X are cos theta, where the r is 2. So 2, okay, only theta, you change it to t. And then the y is 2 sin t. T from 0 until 2 pi. For anti-clockwise circular curve, you can use an equation similar to your polar coordinate, which is anti-clockwise direction. So x from 2 cos t, y is 2 sin t, t from 0 to 2 pi. Okay, so this question, if you want to evaluate the line integral, the line integral you can get x. And then from the parametric equation, you put it into RT. Component I is x, which is 2 cos t. Component j is a y, which is 2 sin t. Okay, the curve is on xy plane, that's why component kz is 0. And then you find dr. dr dt, you have negative 2 sin t, 2 cos t, 0. Okay, dt you bring to the other side. So you obtain your dr already, f. Okay, f here, you have to change it into parametric equation. X is what? 2 cos theta. So 2 times 2 total is 4 cos t. Y 3x squared. 3 times 2 cos t squared. Z 0. Simplify your f. 4 cos t. Okay, this is 12 cos squared t 0. If you want to do the line integral, because the curve is 2-dimensional circular, not difficult to get the parametric equations. Okay, but the correct answer is actually using the Stoke is here. Here just for your additional practice. So now, if you do the line integral, f dot dr along curve C, the f you have 4 cos t. This one is 12 cos squared t 0 dot with your dr. To obtain this negative 2 sin t 2 cos t 0 dt. Okay, this is f. dr you have negative 2 sin t 2 cos t 0 k dt. So the t came from 0 to 2 pi. T from 0 to 2 pi. So you evaluate the dot product. Lastly, integrate respect to t. So 0 to 2 pi. Then for cos t multiply negative 2 sin t. So you have negative 8 cos t sin t. Okay, component j plus 24 cos cube t. Component k is 0. So dt. You can just use calculator to get a quick answer. So negative 8 cos c plus 24. Okay, the cos cube, I will put a bracket there. Cos and then cube 0 to 2. Quickly you get answer 0. Okay, this is evaluate the line integral. But the questions, if the question is here, this one, if the question give this one and they said use Stoke theorem, if you evaluate the line integral, you sometimes they may give you 0 mark because you not use Stoke theorem. Stoke theorem you have to evaluate this one. Okay, the curl of f dot n ds. In the plot integral curl of f dot n ds. Okay, and I show you the line integral here is just for the purpose for your practice. Because the curve C, 2D and circular is not difficult to get the parametric equation compared to the tetrahedron. Tetrahedron difficult and tedious, and you have to do it 3 times because C1 different parametric equation, C2 different, C3 different. And normally the curve in 3D and is a piecewise smooth curve connected close to form the surface S. Then we use the Stoke theorem. The simple integral like this question is actually you use a line integral, but the question give this one you have to evaluate here. So same with the rest of the questions. Okay, so do you have any questions here?
No, doctor.
Okay, the full solution later on I will upload to the portal. And then the rest more or less is the same. You have to f dot dr, then you have to find the curl of f. Everything you have to find the curl of f. Okay, like question 4, okay, of course, okay, when you have a question 4, 5 tetrahedron, then will be easier you use this one. Use Stoke theorem. Triangle hypothesis. This is a of tetrahedron surface. It will be easier you find this one. 5 also. Only you have the curve is actually the boundary of the circle, sphere, hemisphere of cone. Okay, then if the question said verify Stoke theorem, then you have to do left side, right side. Means you have to do the line integral f dot dr. The curve C here. The boundary of the upper cone is circular, then not difficult to find your line integral f dot dr. So verify Stoke theorem that you have to do both hand side. So the equation verified, then only you have to do both hand side. Okay, the book K is exactly given by F dot dr. So part A is actually asked you to do the line integral F dot dr, verified, so you have to do the right hand side. So left side equal to right side, then verify as what I did just now. When I do left side, right side, okay, this is actually you verify the Stoke theorem. In like question 1, I show you left side, right side. So this is equivalent to you do verify the Stoke theorem. Okay, and then so now it's 9:30. You may go to your author to do the last quiz, quiz 5. And then please those who haven't filled in the spot, please fill in so. Today is the last day. So I wish you good luck and your test. The final is 13 July, right?
Yeah. Yes.
So now you may go to your author to do the last quiz. Only then by today I will finalize all your coursework mark. You can look at the map there.
Okay, Doctor.
So those who haven't filled out,